Okay, on to some slightly more difficult algebra problems. These all involve squares of the variable we're trying to solve for, x. So we're going to have to take some square roots. So in number 1, we'll first move that 7 over to the right side by subtraction. Always do the easy stuff first. Then we end up with x squared is equal to 2. In order to find x, we have to take the square root of both sides. Remember that taking the square root of x squared is really asking the question, what do you need to multiply by itself to get x squared? And the answer is x. So that's how we get x out of that. Now we also have to remember that the answer is plus or minus square root of 2. And we can just plug either plus square root of 2 or minus square root of 2 into our equation and see that they both work. And the reason is that when we square a negative number or a positive number, we get the same positive number out. So you can see that both of these solutions, plus and minus square root of 2, work. We'll do number 2 in an analogous way. First, pick the low-hanging fruit. Move that 4 by addition over to the right side. So we have x squared is equal to 16. And that's an easy square root to do. Take the square root of both sides, and we'll get x is equal to plus or minus 4. Number 3 is just a little more complicated. We have a 2 multiplying the x squared, so this will be a 3-step problem. First, move the 1 to the right side by subtraction. 2x squared is equal to 10. Then peel away that 2 by division, so we have x squared is equal to 5. The 2's cancel on the left. And then take our square root, so we have x is equal to plus or minus square root of 5. Number 4 is done in a similar way. First, get rid of that 4. It's the easiest thing to do. Add it to both sides. So we have 3x squared is equal to negative 1. Negative 5 plus 4 is negative 1. Then divide by 3. We're on our way to getting the x by itself. So x squared is equal to negative 1/3. And now we have a problem. We take the square root of both sides, and we'll be taking a square root of a negative number on the right. Eventually we'll see that there is a way we can do this. We have to invent new numbers called complex numbers. But for right now, we'll just say that this one has no solution. Numbers 5 and 6 have fractions. So the first thing we'll do is subtract 2/3 from both sides of this equation. So x squared is 9 minus 2/3. We'll multiply the 9 by 3 over 3 to get a common denominator. So we have 27/3 minus 2/3 is 25/3. We'll take the square root of both sides of that equation, and we end up with x is equal to the square root of 25/3, which is equal to the square root of 25 over the square root of 3. And the square root of 25 is 5, and we'll just leave the square root of 3 as it is. Now there are some people who would want you to do what's called rationalizing that denominator. They don't like radicals in the denominator. It's not really a big deal to me, and we won't fuss with it just now. Number 6, we'll add 3 halves to both sides. So we have 3x squared is equal to positive 9 plus 3 halves. So multiplying 9 by 2 over 2 gives us 18 halves. So we have 3x squared is equal to 21 halves. Now we divide both sides by 3, which is the same as multiplying both sides by 1/3. And we end up with 3 divides into 21 and gives us 7, so we have 7 halves. So taking the square root on both sides gives us x is equal to plus or minus the square root of 7 halves.